What's the spring break schedule?
What?
Spring break.
Spring break?
Was the official one, I think it's in April. Your calendar has the last week of March.
Last week? That will be January. No, February. We start at 31st January.
Fam, what, are we gonna be going over today? I'd like to open it up on my other computer.
What can I do?
Which PDF?
Oh, what PDF on the handout?
What are you gonna be going over today so I can open it up?
Oh, after the test, after the quiz, I go back to the diode.
Oh, we're having a quiz today after all?
Yeah, it's running right now.
I don't see anything. I just see you.
Uh-oh.
I don't see either.
Yeah, I didn't know that.
There's no quiz up on the on your homework assignments anymore either.
The quiz only running. Okay. The guy didn't see it?
No.
Nope.
Okay. Okay, just a minute. I try to see.
You're talking about the quiz that's in the handouts. That's what we're supposed to be filling out.
Now the quiz is depending on, okay. Just a minute, okay?
Sure.
Okay.
Okay, let's see.
But what I'm saying is there's no quiz form to download anymore.
No download.
No download up there.
Yeah.
No download on the homework.
There is an answer sheet under the handout section.
Okay, can you see now?
Yeah.
You see
Yeah, we can see that.
the quiz running right now? Do you see it?
Okay, hang on. Yeah.
Okay, go ahead and do it.
Okay.
Right, and we fill out our answers on that quiz report that's under handouts, correct?
Exactly.
I don't see a quiz report under handouts, but
You have to go to the web. Okay.
yeah, no, I'm there, but I already downloaded. I was just mentioning it for other people because it used to be on the homeworks list and now it's not.
It's not on the homework.
Oh. Oh, okay.
The quiz only running in the Zoom. If you don't have a quiz report right now, just write down number 1, A or B or C, and later on you can download the quiz reports and upload it.
Okay.
Next.
going home.
Did number 12 repeat 2 times?
Now I cannot answer you. Okay, we'll see.
Okay. Sam,
Yeah,
is it test?
what?
Is it test or is lecture? Is it test?
This is the quiz.
I came late.
You see that?
Yeah, I
Okay.
see, but I
That's
can't
what-
write down.
That's what you have to do.
I have to write down.
Now, you have to make it your choice for each question A, B, C, or D.
Okay. And choose one answer.
Number 12 repeat 2 times.
Okay.
You have two
If
number
we look
12.
at question.
Yeah, just make it the next one. There's 16 on the paper, so just make it the next one. It works out.
I will be looked over, okay? Basically, I given you the chance to upload the answer around 24 hours.
Okay. Question.
Uh,
Yeah, that means after today, you can look back into the video on the web,
Okay.
okay? And try to do what you're missing.
No, okay.
so just to be clear, so number 15 should be answer 16 on the sheet, right?
Yeah, that makes sense to me.
Okay, that doesn't matter. I will be looking into that. I couldn't believe it. They duplicate and I don't know.
Well, the sheet says there's 16 answers, so that's what I was asking.
Okay, 16 questions.
So how long do we have? How long do we have to do that quiz?
Yeah, that's how the quiz will be look like.
How long do we have to finish the quiz, to upload it?
Okay, so basically, you have to go into the website, download the quiz, right? You have to fill it in a number 1, A or B or C or D, and so on. Then you can upload
But
it.
how long do we have to upload the quiz?
Right.
24 hours, you said?
Yeah, that's what I said. I given you 24 hours.
Thank you.
If you're missing some question, or if I did wrong something, I correct that, no big deal. But that is the quiz. Okay, now I try to explain to you. The quiz That means the question close to the job interview. That means that something when you look into that and you're able to answer without anything. That's a very, very important for anyone try to looking into the technician job. More you do, you get along. Okay? The thing is not involve too much calculation. The thing in the field, they don't care about calculation. They care about how can you do. Okay?
So what you're saying is they care about also how fast you can do it.
Yeah.
Okay.
They just want to see how much you understand. Basic for electronic. And the company will be training you. But they're not training how, you understand that simple circuitry you're able to do.
PN junction. That is blue.
Sorry. Hello? Do you hear me?
Yeah, we can hear you.
We do
Okay.
now.
Yeah. I still get a little problem. Okay, anyway. This is basically the diode. Okay. And they're using either two different types of semiconductor to build the diode. Number one, silicon. Được nghe nhiều. Okay. So basically physical, you get a positive side and a negative one electron here. Okay. And this is the depletion region. If it's wider, that means electron cannot move it. Then the diode will be open, not working. If the electron from N-type can move into the P-type, that means you get a current. Okay, so we don't care about much physical, we care about that one. Okay, this is a simple for the diode. And the voltage from anode to cathode here, that's what they call a VD. VD, that means the diode voltage equal VA minus VC. Okay. So this what they telling you. Okay. This is they say ideal diode. What that mean ideal diode? That means VD equal 0 volt. And another one, that they can be diode open or on or forward bias. If they open, like the switch is open, current cannot flow it. If they on, that means the current can be flowing from anode to the cathode, okay? And basically, we don't do anything with the ideal diode. That never happened. Now, this is the real thing, okay? When you get a diode, okay, and they can be open, this open. Okay, that means the voltage VD less than 0.7 volt. Okay, VD less than 0.7 volt for silicon, and that will be on. Okay, now that means VD greater than 0.7 volt. That only telling you one thing. When the diode on, then you cannot draw this diode anymore. You must be substitute the diode by the battery, 0.7 volt. Okay? That is very important to you. Now, when you're looking into this circuitry, whenever you're working with the diode. Oh, sorry, working with a diode. Before you want to do anything, you have to know the diode on or off. Okay? If you don't know they on off, you cannot solve the problem. Okay, so the example one here. Can you tell me the diode will be on or off? For that one.
It's on.
How do we know that on?
Because the VD is showing 0.7 volts.
VD. You said that is 0.7 volt in here, right?
That's what it says right there.
No. That means any diode, they can give you VD equal 0.7 volt or VD equal 0.3 for the manual diode. Okay.
Oh, sorry. I thought that was saying it's reading 0.7. Okay, never mind.
Okay. What I'm saying is when you're working with a diode, if you don't know it on or off, you cannot do anything. So you have to tell me, is it they on or they off for this example?
It's on
It's on. How come?
because you have 10 volts going to it and it breaks the threshold of 0.7 volts.
Okay. Now, before you can say the diode on. Okay. You have supposed to be no diode here. What we out?
Would be 10, right?
Perfect. That have to be 10. All right. The thing is, we suppose no diode, that means they open. They open, that means the current flow to the R limit will be 0. So the voltage on this side and the voltage on this side will be the same. That's why you get 10. And now, for this diode here, you get 10 volt in the anode, 0 volt in the cathode. That's higher than 0.7. That's why we say diode on. Okay, so the answer will be a diode will be on. Okay, now what I'm saying is when you say the diode on, you cannot leave a diode here. You have to substitute the diode by the battery. Now the diode will be look like YT negative 0.7 volt. You see that? And now the question is what Vout equal?
Is it 9.3?
I ask you, if you are using the meter DMM to measure voltage on your car battery, what do you think you get the voltage?
On a car battery, 12?
12 volt.
Yeah.
Okay? So that only telling you one thing. When you measure the voltage across the battery, you get that voltage battery, right?
Yeah.
So that's why 0.7 volt here is the battery. So if you get the VMM connect high side here, Okay. High side on this side, low side on ground. What you get?
Is it changing it to 0.7?
Yes. You measure
Oh.
across the battery 0.7.
Got you. Okay.
Then you get that. That's a very important to you.
Yeah, I
Okay.
get it. Yeah.
0.7. And now they're asking for the current I. The current I go this way. So basically you take a 10 divided to 1K, right? But you have to know right here is 0.7 volt. So I equal 10 minus 0.7 divide 1K. Ohm law. Okay. So 9.3. milliamp. And if they want the VL cross R, VR equal I time R, that will be equal 9.3 milliamp. Okay. Time 1K. Okay. So milliamp times 1K, then you get a volt. So VR will be 9.3. Okay. Now you're telling me. Example number 2. What we have? First thing you have to tell me diode on the example number 2 on or off.
It's off.
They will be off, right?
Yes.
Why? Okay, I'm telling you. Same thing like the first example. If you don't have a diode, no diode here, then Vout will be equal 5 volt. Without the diode. And now you get a diode. You get one side 5 volt, the other side 0 volt. So the diode will be off. Okay. And what Vout?
It'll be set. It'll be a 0.
No, they open right here.
So it'll be 5 volts.
Exactly. What is the current I?
Wouldn't there be no current flow if there's an open circuit?
Yeah, they open circuit, but they're asking about the current flow here.
That's 5 milliamps. Oh, 0 amps. Oh, I see what you're saying.
Open. Current cannot
Oh,
flow.
it's completely open.
Yeah,
Oh,
that's what I was
got you.
saying.
Oh, okay, okay. I thought he was saying the diode wasn't there.
No, and
the
Got
flow
you.
yeah,
across R. That means they're asking the voltage across here.
But isn't that the same no matter which direction the diode is put in the circuit? If the diode is off, there's no current flow, right?
Depend on the circuitry on this one. Off means they open. Okay? They open
Right.
here. So the current cannot flow.
Right. No, I was just saying if the, correct me if I'm wrong, if I read everything correctly, the diodes are what are only allow flow in one direction, and that the line with the triangle pointing at it, that tells you which direction it's going. So if the line is first in as current or is flowing into it, it will prevent any flow. If it's turned the other way around, it allows flow if it gets enough voltage. Am I wrong in that?
Yeah, the diode look like that one here.
Right.
Here.
And the whole point of the line is to tell you, the line actually tells you which way the diode's basically pointing, which way the current is supposed to flow. And if it's turned the other way around, no matter what you put through it, current and voltage is not going to go through it because it's only designed to go one way, right?
Exactly. Just flow only one way from A to C. They only go this way. They cannot go C to A.
So in this second example, the only way that the diode would be open is if the voltage, the battery, was actually on the other side, or there was a second battery on the other side between the common, the ground, and the diode, correct?
Right. So when they open here, that means current cannot flow it. The thing is the open circuit. And the voltage Vout will be equal to that voltage here. And the last one, what the voltage Vi here?
That would be 0 since there's an open circuit, right?
Perfectly. The thing is I equal 0. You calculate the VR will be I times R. The thing is the circuitry open. I equal 0.
No, V would be 0 because 0 times anything is always 0.
Exactly. Okay. Question 8. Diode on or off?
As on.
Look like they would be off, right? You know why? This
Because of the battery?
This side you get 5 volt. Okay? That's the anode, right? The other side you get 8 volt. This side higher than this side. That's why VD will be less than 0.7. So the diode have to be off. Okay? When they off, what happened? They will be look like open. What the current I? That's the current flow here. Forget that one. They open.
Right, so no current flow.
As volts.
Current I equal what?
.5?
The thing is open, so the current cannot flow here. Okay, current will be flow, go this one, go here. Okay, and they open, so that's why current cannot flow it.
Oh,
What I am telling you one thing. When you say the diode on, you have to substitute diode by the battery, 0.7 volt. And then when you say the diode off, you substitute diode by the open circuit. That is the key point. Okay, now example 4. Diode is forward bias or reverse bias. Forward bias means on. Reverse bias means off.
Should be on.
No, it should be off, right?
Yeah, I think it's off.
Now, okay. The voltage here. So, if you know the voltage here higher than 0.7, they will be on. VD higher 0.7 volt on. VD less than 0.7 off. So now, if you're looking through the circuitry telling me they on, that means forward, or off, that means reverse.
But Professor,
Yeah.
isn't this showing negative going to common or going to ground? You can't negative going to ground doesn't provide any voltage flow, right?
Now, you get the route right here, right?
Right.
What's the voltage here?
That's 100.
What's the
Between what point? Between that and ground?
100.
This voltage here connect to the power supply.
Right, but if you
100
measure
volt.
thing on the negative side, it's going to be 0, right? Because you have to.
Right.
There has to be
No,
potential.
no. I mean on positive here.
Between those 2 points will be 100 volts.
Okay, now I tell you. This route 0 volt, correct or no?
Yes.
Okay, this side 0 volt. Okay. I want to know this side, how many volts?
Between that and the positive would be 100 volts, right?
Is it correct?
Is that a negative 100?
Yes, this is negative here.
Right.
So the diode on or off?
off.
Yeah, the diode's off.
Okay, now. A here. C here. this ground. This minus 100 volt. So VD, that means the voltage here equal VA minus VC, correct? And VA is ground zero minus VC. VC will be minus 100. Will be not 100. So you say VD equal 100 volt, they on or off?
Should be on.
They must be on. Higher than 0.7, then they on. So that's why, you have to get a very understand about the basic, so you don't have any problem later. When you in the field, they give you this symbol here. Okay? They say this is round and this is a 2 volt. They just asking you, diode will be on forward bias or reverse bias. First thing you know, this is a VD. And VD will be equal. That will be anode, that will be the cathode, VA minus VC, VA 0 volt, and VC 2 volt. That's why you get minus 2 volt. So they will be off. They must be higher than 0.7, so they can be off. I think if you not quite understand the basic for the diode, and when we go into the next one here, they call a Zener diode. Can give it you a little more problem. When you see this symbol here, that's what you call Zener diode. Okay? Diode, normally they not go this way. Zener diode, and this will be anode, and that will be cathode. Okay? Now, they get two things. First thing they say, break down diode. Okay? That means if the diode break down, you must be substitute the diode by the battery. Okay? With the voltage, will be any voltage. When you go to buy a Zener diode, they can ask you what voltage you want. You say, okay, 10 volt. Then this will be 10 volt. You cannot make up that voltage. That voltage goes with the Zener. Okay? Second thing, also the Zener can working like normal diode. So when they go to the normal diode, then this side here, cathode right here, see that? And this will be anode. And you substitute the diode by 0.7 volt. Okay? Now, a major application for Zener diode is add a type of a voltage regulator for providing stable reference voltage for use in power supply of meter, voltmeter, and other instruments. You understand in your computer. Okay? Your computer basically they're using 5 volts. So they have to get the Zener diode with the 5 volts. That means when the Zener on, they will be 5 volts. Okay? Otherwise, they can be off. Power supply, same thing. You want 15 volts. They need the Zener diode will be 15 volts. And they want it higher than 15. They cut it down. Otherwise, they can damage inside. Okay? So basically, Zener diode, we need to guarantee for no matter what the voltage you want, depending on what voltage on the Zener. Okay, now. For the circuit itself, and you understand it right here. What that means? That they telling you VG equal 10 volt. Okay? That means when you go to the electronics store, you want to buy Zener, they asking you what voltage you want. Then you can say 10 volt. So I'm telling you, the purpose of this Zener, okay? That will be telling you if you get 100 volt here, Zener will be break down. Then you only get 10, no more. Any voltage higher than 10, they cut it down. Okay, that's how the Zener working. Now, for the circuit, so they given VG 10 volt. Question A, what VEV out if V in 20 volt? Now you get the 20 volt here. The question A, they want to know what V out here. Same thing, like normal diode. For the Zener, you have to know the voltage here without the Zener diode. If you don't have a Zener here, my question is what voltage right here?
Should be 20, right?
Perfect. They will be 20. When I say without the Zener, that means look like we don't have a Zener here. Then they get 20. Okay? And now with the Zener, question is what we out?
Is it 10?
Perfect. 10 volt. That's only telling you any voltage in this case higher than 10 volt of Zener, they cut it down. Okay? And they say, what is the current through to 20 ohm? Okay? So now we say Zener will be breakdown. And that is given to you voltage here will be 10 volt. Okay? So answer will be V out Okay, and now they asking about question current here. Okay, what is current? I. This is the Ohm law. Okay. I will be different between 20 minus 10 divided 220. Okay. Up to number A and B. Any question? Okay, if no question, now go to C. Now they say not 20. Now they say 5 volt. Minus 5 volt. What is the current? What is V out and the current to resistor?
Is it 0?
Okay, minus 5 volt. Okay, so again, without the zener, what voltage here?
-5.
Perfect. Minus 5. Okay. So the zener not break down, right? Only the voltage on this side higher than 10, they break it down. However, minus 5, they not. Okay. You get the 0 volt here. And you get a minus 5 on the other side. So the question is what V out equal?
Is it, well, is it 10? I don't know.
Now I'm telling you here. That's what they given to you.
Oh.
They just like normal diode. They not break it down. They just like normal. Okay.
Okay.
So if they look like just like normal, that means you can get the battery positive here, negative the other side. This is a positive. This is a negative. So you can see VD equal 0 minus VA minus VC. 0 volt minus to minus 5. Is it 5 volt? Correct?
Yeah, that makes sense.
Okay, so what we out? That means now they will be, diode will be on. Okay, you want to measure across the diode, V out. So V out, they will be equal. That means they measure across the battery. Minus 0.7. So that's why they get minus 0.7. And they want the current through R. So basically, the difference between minus 0.7 minus to minus 5. Okay, divide 220. And that's coming up with 4.3. Okay. Any question? Okay, now try this problem. They say for this circuit shown for no load, first thing they supposed to be no this one no here. And zero with a V zero equal 12 volt. First thing they want to know what the current IL. That means I of the load. This IL here. First thing you're telling me the zero breakdown or not breakdown. When you're working with a diode, if you don't know diode on or off, you cannot solving any problem. Second thing, when you see the zero, then you have to say the zero breakdown or not breakdown. Okay, the zero breakdown or not.
You should, yeah.
Now, if you set the zero breakdown, then you have to prove the voltage here have to be higher than 12. That's a zero voltage. Then they break down. Otherwise, they not. Same problem. When you're working with the zero diode, so you have to support this is not here. Don't have a zero here. Also, you don't have a RL here. That's what they said here. No load. Okay? So if I don't have a zero here, what the voltage at this point?
24.
What the voltage?
I think he said
20.
24.
24. Correct? That means open, right?
Yep.
This open. No current flow. So the voltage on this side and this side the same. Okay? So you come up with the voltage here which is supposed to be 24 volts. Now, 24 volt compared to VG 12 volt. Now you can say they break down or not.
Yes.
Yeah, right? They break down. If they break it down, you cannot get 24 volt here. What voltage here?
12.
Perfect. Look like you understand. 12 volt. Okay? So now you get a 12 volt here, 24 volt here. Okay? And the question right now, they asking IL. What current IL? No load. Okay? That means they open here.
Professor.
Yeah.
So if I'm looking at this correctly, you would treat this like a parallel circuit or a series circuit?
Which one is very parallel? Right now, they said no load in here. You don't have a dead one.
Right.
Okay, they just one circuitry theory. Only here, right? Cannot here. They say no load. You don't have any resistor here.
Right.
However, they asking you what is IL? IL equal what? Zero amp,
Yeah, 0.
right? If you don't have a load in here, they open. Current cannot flow to open.
Right. Right. I'm just a little confused because you're showing the 12 volts up above, so that's what I was like, okay, wait a minute.
And the night IG. IG, that means general current. That means the current flow here. So IG equal one side 24. The other side 12. Divide 470. That's how we can get IG. Okay? And now they can want to know V out. Right now, it's still no load, okay? What V out?
24. Oh, wait, V out with load. That would be 12.
No load, right? Right now, we still no load, right?
Oh, you're talking C. Okay, for
Right,
C. Okay, yeah, that would be 24 if I'm
No.
understanding correctly.
No. Well, the thing is, you get the diode here, and you already said without the zener, you get 24 here.
4.
So that's why they have to break down. When they break it out, then they only 12. Okay? And now they can telling you about D. Now with the load. We are with the load. Now they connect the load in. What we are? CD. same thing. Still be 12 volt. The thing is, you know, break it down anyway. And E, they want I load. So right here you get 12 volts. 12 volt right here. Ground right here. Easy to calculate the I load equal 12. Divide 490. Okay? That one IG. How come you calculate IG at this time? Okay? I can tell you. You can calculate the I total. Okay? That means 24. You get 12 volt here. Okay? So IG equal 24. Okay? I total. Sorry. I talking about I total. Right here. I total equal 24 minus 12 divide 470. Okay? And now the question is, when you get the load, they want to know what current IG. Okay? In here, you can get 24 minus 12 divide 470. Let's see. 12 divide 470. You get 0.0255. I times 1,000 to get milli.
Can you write that out?
Yeah, just a minute. Okay, let's see. I total equal 24 minus 12 divide 470. And times 1,000. 25.5 milliamp. Okay? And when they coming up here, then you already know the current for IL. IL will be 12 divided 490.
Say divide by
24.4849. milliamp.
So if I'm understanding this correctly, answer B of IZ by itself is the same answer as F, or am I missing something?
Okay, you say ID.
So
Okay,
with the load and without the load, it's the same?
no. Why? I telling you one thing. Now, if we don't have a load here, okay, so the current will be flow this way. You see that?
Yes.
So that current will be take 24 minus 12 divide for 70. Okay. Now, if you get the load, so if you get the load in here, so you take the 12 divide RL. That's why you get 24.49 milliamp for the load. And the total current here. This is the total current here. When they go up to this point, one go to IL, one go to IG. Okay, so the total current, that means you want to know the current right here. That's what we already calculated, total current. Okay, you take 24 minus 12, okay, and you already divide by 470. That means the total current 24.49. Okay, and now you can see 12 divide to 490. That means IL. Okay, you get the IL equal 24.49, and the total current here you get 25.5. So IG in this case will be the difference between 25.5 minus 24.49. So the answer for IG here will be equal, let's see, 25.5 minus 24.49. $1.01. Therefore, F, okay, that will be the answer for F. If you really understand the diode and the Zener, you can see a really very exciting. Okay. Now,
Mr. Pham, real quick.
yes, sir.
Maybe the lady can jump in and help me out. Where underneath the circuit that you wrote down Zener breakdown or not, and you said IZ is equal to 24 minus 12 over 470, and then in the upper left you got IT is equal to 24 minus 12 over 470. So are you? So it sound I don't know if that's what she was saying, but it sounds like you're saying IZ and I total, the way you wrote it, sound like they're the same.
Now, first thing, I just quickly go over that thing.
Do you see what I'm talking about?
Yeah. Yeah. Just a minute, I'm telling you. Okay, now, first thing, you say no load, right?
Correct.
If no load, that will be telling you open here,
Correct.
okay? So, if they open there, and now you see the Zener,
Correct.
then you must know Zener in this case breakdown or not.
Right.
How do we know? How do you know the Zener will be breakdown or not?
Well, one of the things is I don't know how other people would look at it, but I also look at the supply voltage is 24, the Zener is rated for 12, and 24 is greater than 12.
No, that's not quite. What I'm saying is, when you're working with the Zener,
Correct.
then you have to know what the voltage in here. That means first thing you're supposed to be no Zener. If you don't have a Zener here,
Then it's 12 volts where that dot is at.
no,
I mean, 24, excuse me.
then voltage here will be 24.
24, correct.
And 24 higher than 12.
Correct.
So
And
that's why to change Zener breakdown.
Right.
Okay, now, if you say Zener breakdown, then the voltage at the here must be correct.
When the Zener's in breakdown, then the output should be 12 volts.
That's what I said. Voltage here have to be 12.
Correct.
Okay? And now they asking for I load. That means they're asking for what current IL right now.
But you don't have an IL.
IL equals 0.
Correct.
Okay, the thing is open.
Right.
And now they're asking for IG. That means the current here.
Correct.
Okay? So basically you get a 12 volt, 24 volt here, 12 volt here. You can calculate the current I total. Right?
Wait a minute. That's you're calculating IZ there, right?
I total. I total or IG the same.
Okay. That's one of the things we were saying. Okay. I total IZ is the same. Okay.
And basically they will be 24 minus 12.
Okay. Divided by 470.
Exactly.
Okay, so in this case, without the load, this is without the load, but the Zener is still there. It's 24 minus 12 over 470, and that is equal to I total and IZ.
Exactly.
Okay,
Now, you get the load.
right.
And you already know this will be 12.
Correct. The output's the same because it's in breakdown.
Yeah. 12 volt and you get a 490 ohm load, you can calculate IL.
Correct.
IL equal 12 divided
By 490.
Okay? So basically the current flowing here without the load, you can get I total or ID will be the same. And now you get the load. Okay? So the current I total going here, one go to the Zener, one go to the IL. You already know IL. You have to find the difference between IT. Okay? That means you have to take IT minus IL. That's why you can get the current IG.
Okay.
The thing I total come here, go down IG, go here IL. You know IL. Then you can calculate IG.
So in this problem, I guess the main thing is we have to remember the first part is with no load, and then letter D is with the load.
Right. The thing in that quiz you will be working on diode and also the zener. Make sure if you confusing anything, okay, go ahead and asking me, okay? So anyway, that's good enough for today. And make
Good.
sure we don't have a class
Thank you very much.
on Friday and Monday. We'll see you guys on Tuesday. Okay? And
Yeah.
anything, if you need help by whatever, let me know. And I can tell my lab instructor to help you out. If they cannot, I can help you out. Like, right now, you working on the assignment, deal with the multi-sim saver. Okay? If you really don't know how to do what to do, whatever you guys get a problem, let me know.
Okay, thank you.
Like you want the program, you can work at your computer at home. I can telling you. Okay? Copy MSIM7 installed in your computer at home. So you can do it at home easier. Okay?
Yeah.
But
Okay.
anyway, next will be the holiday, okay? I wish all of you guys will be get very good time during the holiday, and we'll see you later, okay?
Okay, we'll see you next
You
Tuesday.
too. Thank you.
We'll see you
Thank
guys
you.
later. Bye-bye.
Bye.
Bye.